Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR NET, GATE, NT exam, PhD exam, SET exam, PIFR, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the lecture number 19 of Condensed Matter Physics. Okay, and also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. And also guys, please share my details, my lecture details with your friends so that they will also be able to watch my free live lectures and will be benefited from it. Okay, so let's get started. So I'm solving question. Okay, so there's a question. Question is, we have been given dispersion relation, that is E, which is function of k equal to minus 4 epsilon 0. Okay, cos kxa by 2 cos kya by 2 by 2 plus cos kya by 2 cos kza by 2 plus cos kza by 2 plus cos kxa by 2. Okay, so this is the dispersion relation which is given, guys. Okay, so we have to find out the x component, the x component of velocity, of electron. Okay, so x component of velocity of electron at pi by a comma 0 comma 0. That's what you need to find out, guys. Okay, on options are given. Options are number. First option is minus 2 epsilon 0 a upon h cut. Option B is 2 epsilon 0 a upon h cut. Option C is minus 4 epsilon 0 upon h cut, epsilon 0 a upon h cut, and option D is 4 epsilon 0 a upon h cut. Okay guys, so this is the question. We have been given this dispersion relation. Okay, E, which is function of k equal to this, and we need to find out the x component of velocity of electron. Okay, at this pi by a comma 0, that is kx value is pi by a, ky value is 0, and kz value is 0. Okay, okay, so I'll solve now. So guys, we know that Vg, that is group velocity, is d omega upon dk, right? Or we can do one thing. Vg is going to be, we can multiply by h cut and divide by h cut. Okay, so this is going to be h cut omega is E, right? So del E upon 1 upon h cut we can take common, and this is del E over del K, del E over del K, right? This is the Vg since h cut omega equal to E. Okay, so this is the one. So now we have also, or we can write Vg equal to 1 upon h cut dE upon dk. We can do one thing, we can multiply by dkx and divide by dkx. Okay, this is dkx and then kx upon dk, right? We can write like that. Okay, so d upon dk, we have divided by kx and multiplied by kx. Okay, dkx and dkx. Okay, we can do like this. Okay, so now we'll solve it. Okay, so here you need to understand the value of dkx upon dk, or we can, this you need to know. Okay, and or dk upon dk upon dkx, that value is going to be equal, this value is equal. Okay, and what that value will be in this case, now you need to understand this, guys. This is equal. Okay, since we know the k means kx I cap plus ky j cap plus kz k cap, right? This is the k, guys. So from here we can write kx ky kz value, right? Mod of k is going to be, this is vector k. Okay, mod of k is going to be root kx square plus ky square plus kz square, right? And since we have been given this value, kx value is pi by a, ky value is 0 and kz value is 0, right? So this is going to be, value of k is going to be root pi by a square plus 0 plus 0. This value is going to be pi by a. So this is the pi by a value, right? So here this is the we can call it equation number 1. Important. Okay, this you need to understand, you need to note down Vg equal to that 1 upon h cut d upon del kx into del kx upon dk, right? This one. So d upon dkx into dkx upon dk, right? This value is equal, guys. Okay, so from here value of k is pi by a, right? Or we can write this is kx, right? Or we can write like this, kx square, because this value is given 0, right? So this is kx. So k equal to kx, guys. This you need to understand, k equal to kx. We can write like that, kx, that is pi by a, like this, pi by a whole square, right? And this pi by a value is kx. So k equal to kx means here we can do, so now equation, this Vg value is going to be, 1 upon h cut del e upon del kx into this, you need to understand, guys, here kx upon k, value of kx is, kx, right? K is kx, right? K is kx. So so this is going to be del kx upon del kx, and del kx upon del kx value is 1, right? If you differentiate that kx with respect to del kx, that is going to be 1, right? So this value is going to be del kx upon del kx, because this value is kx. And guys, this question is asked in CSIR net 2014. Okay, this question is asking CSIR net 2014. Okay, so this is the Vg value is this. Okay, so this value is going to be 1, then Vg value is going to be 1 upon h cut del e upon del kx, and this value is Vg, right? This value is x, this is the x component of velocity, x component of velocity. So okay, so here the value of Vg is going to be 1 upon h cut. Now you understand, this is 1 upon h cut del u upon del kx. Okay, this Vg is x component of velocity. Okay, x component Okay, so here 1 upon h cut. Now we'll differentiate this del E upon del E, that E with respect to kx, right? This is kx, so we are differentiating this with respect to kx. So this value is going to be minus 4 epsilon E, minus 4, it is not epsilon, it is E naught, right? Okay, E naught, and this is E, 4 E naught. And now we'll differentiate this with respect to kx. So this is going to be kx we are going to differentiate. So this is a by 2 cos kx by 2 is minus sin kx by 2, this differentiation. So this is going to be minus a by 2 sin kx a by 2, kx a by 2, and this will remain as it is, that is cos ky ky a by 2, cos ky a by 2 plus, well, so this this y and this we are differentiating with respect to kx, right? So this is y and z, so this value is going to be 0. Here kza by 2 will remain as it is, cos kz a by 2 will remain as it is, and we'll differentiate this one, cos kx a by 2. So cos kx by 2 is minus a by 2 sin kx by 2, right? Because differentiation of sin is minus a by 2 minus a by 2 sin kx a by 2, right? This is simple differentiation. So from here the value Vg is going to be a by 2, we can take common. So and we'll take a by 2 common, 2 will cancel for 2 times, right? So this is going to be minus 2 epsilon 0 a upon h cut, we can take common, and this value is going to be, and minus also we can take common, minus minus plus, and this value is going to be sin kx a by 2 cos ky a by 2 plus cos kz a by 2, and this is sin kx a by 2. Okay, this is the one. So now we'll find Vg at pi by a comma 0 comma 0, because we need to find out this one, this x component of velocity at this. Okay, so this is the x component of velocity, right? And now x component of velocity at this value, this is going to be 2 epsilon 0 a upon h cut, and here we will put, this is sine, if you put pi by a here, pi by a will get cancelled, this is going to be sine pi by a, pi by 2, pi by 2 is 1 into cos 0 1, plus here cos 0, because kz is 0, right? Cos 0 is 1 into sine kx, in place of kx will write pi by a, right? A will get cancelled, this is going to be sine pi by 2, means 1. Okay, so this value is going to be, this value is going to be 2 and 2, this is 4 epsilon a upon h cut, 4 epsilon a upon h cut. So this is 2, right? So this is the answer, guys. So which option is matching? 4 epsilon 0 a upon h cut, right? So which option is matching? Option D is matching, 4 epsilon 0 a upon h cut. So this is the answer, guys. Okay, next question. Meanwhile, just let me check whether I'm audible or not, then I'll proceed further. It. So I'm solving question. I'm audible. I'll proceed further. Next question is, question number 2. Question number 2 is, this one, guys. So question is, in Cu, that is copper, drift velocity in Cu, drift velocity of electron in a electric field of 500 volt per meter is 2.17 meter per second. Okay, so in copper drift velocity of electron in electric field. Okay, in copper is a conductor, right? In copper, the drift velocity of electron, the free electron's velocity, that is drift velocity of electron in a electric field of 500 volt per meter is 2.17 meter per second. Okay, so we have to, so this question is divided into two parts. So first part is we have to find mobility. Okay, so we have to find mobility. Drift, so we have been given drift velocity. Since we have been given Vd is given, that is 2.17 meter per second, 2.17 meter per second, and E is given, electric field is given, that is 500 volt per meter. So we have been given two things. So it means, and now we know the formula, guys. Vd, drift velocity, is mu E. Mu is the mobility. Okay, so from here, value of mu is going to be Vd upon E, right? Vd upon E. So we can just put the value. Vd value is given, that is 2.17 upon E is 500 volt per meter, and if you solve it, so this value is going to be 0.0043 meter square per volt second, right? This is the answer, 0.0043. Okay, this is the answer, guys. Simple question. This is related to conductor question, right? Next question is, next part is we have to find relaxation time. Okay, relaxation time. So guys, we know the drift velocity is equal to a tau. Tau is the relaxation time. Time is the acceleration, right? This we know. So from here we can write Vd value is going to be, A is F upon m, right? M is the mass of electron into tau. So from here, value of tau, that is relaxation time, is going to be Vd m upon F. So drift velocity, which we have already given, right? That is 2.17, and the mass of electron we know, right? Mass of electron is we know, that is 9.1 into 10 to the power minus 31, right? Have you made any mistake? Tau equal to m, right? So this is tau. So tau value is going to be Vdm upon F. Yeah, this is correct, right? And F value is QE. F is the electric field, right? The Q is the electric, F is the electric force, right? And that is QE. And QE means, since F is QE, right? So here in place of F, I can write QE. So QE means, I can put the value, Q means charge of electron, that is 1.6 into 10 to the power minus 19. into E is electric field, that is given 500. If we solve it, this value is going to be 3.94 into 10 to the power minus 14 second. Okay, so this is the relaxation time, 3.94 into 10 to the power 14 second. Okay, so this is the, so we have another formula as well here, guys. This I'm just going to tell you. This relaxation time tau is also that NE square upon tau. NE square tau upon N. This I have already explained, and also mu value is this sigma. The conductivity is NE. You can note down this as well. So this is how we got the relaxation time. Next question. Next question is, this is a good question, guys. Okay. Next question is question third. Okay, so we have been given this dispersion relation. Okay, EK is given minus 4 E naught into cos KXA by 2 cos KYA by 2 plus cos KYA by 2 cos KZA by 2 plus cos KZA by 2 cos KXA by 2. Okay, this is the dispersion relation which we have been given, and now we have to find velocity. This is not x component of velocity. Okay, we have to find velocity at pi by a comma pi by a comma 0. Kx ky value are pi by a and kz values 0. So this is what we need to find, guys. So this is the velocity we need to find. Okay, so guys, x component of velocity I have already explained. So here there is a formula, guys. Okay, this you need to note down. There is a formula for velocity for this dispersion relation. Okay, this you need to note down. That is this one. Vg, velocity is k upon h cut. Very important formula, guys. You need to note down. Okay, 1 upon kx del E upon del kx I cap plus 1 upon ky del E upon del ky j cap plus 1 upon kz del E over del kz k cap. Okay, so this is the formula, guys. You need to note down. So group velocity is important one. Okay, that is h cut upon k upon h cut into 1 upon kx del E over del kx I cap plus 1 upon ky del E over del ky j cap plus 1 upon kz del E over del kz k cap. Okay, so this is the formula. Now I will solve the question. Okay, so you can directly, so so we are not writing in vector form, so this is the formula, guys. Okay, Vg equal to k upon h cut 1 upon kx del E over del kx plus 1 upon ky del E over del ky plus 1 upon kz del E over del kz. Okay, so now simple, we can differentiate this with respect to kx, ky and kz, and we'll put the value, we'll get the answer. Okay, so Vg is going to be, that is group velocity, that is going to be, we can write. Okay, so this is k upon h cut, so 1 upon kx, okay, here, so this is del E over del kx, right? So del E over del kx means this one, minus 4 epsilon e del e, this will differentiate this and this with respect to k. Okay, this value is going to be 0 because there is no kx, right? So this is going to be minus 4 epsilon 0, minus 4 epsilon 0. What we can do is this, we can take common. Okay, so this is minus 4 epsilon 0 minus 1 upon 4 epsilon 0 into, we'll differentiate del e over del kx, right? So this is del e over del kx, we'll differentiate this with respect to kx, right? So this is going to be cos kx means a by 2 a by 2 minus sine kx by 2, right? A by 2 minus a by 2, we can write sine kx a by 2 and cos ky a by 2, cos ky a by 2. Okay, this is going to be 0 with respect to kx, right? Because there is no kx term here. This is going to be again minus a by 2 cos minus k by 2 sine kx by kx a by 2 into cos kz by cos kz a by 2, right? So this is going to be minus a by 2 cos kz a by 2 will remain as it is. Okay, and we'll differentiate this with respect to kz. So this is going to be sine minus we have already taken. Okay, so minus kx a by 2. In the same manner, we will find this is here, we can do like this. Minus 4 epsilon 0 we have taken common, and this is 1 by kx is also common, 1 by kx, right? Then plus 1 by ky. Now this one del e over del ky. Del e over del ky means del e over del ky. So we'll differentiate this with respect to ky. This term is going to be minus a by 2 cos kx by 2 sine ky by 2, right? This is going to be minus a by 2 cos kx a by 2, and the differentiation of cos ky a by 2 is going to be sine minus, we have already taken ky a by 2. Okay, this term. Now this term is going to be 0 because we are differentiating with respect to ky. So here again minus a by 2 minus a by 2 sine ky a by 2 and cos kz a by 2, cos kz a by 2, and similarly plus 1 upon kz minus a by 2. With respect to z we need to differentiate, so this value is going to be 0. This value is cos ky a by 2 cos ky a by 2 sine kz a by 2, right? Because we have differentiated with respect to kz for this one. Now for this minus a by 2 this one we are differentiating with respect to z means cos sine kz a by 2 sine kz a by 2 into cos kx a by 2. Okay, so this is the differentiation, right? Now we can arrange it. So Vg is going to be, we can take minus common, right? Minus is going to be plus, and a by 2 common, so this is going to be 2. This is going to be, and 2 will cancel 4, so this is going to be 2 epsilon k a upon h cut, 2 epsilon k upon h cut, and this value is going to be this one. And also what we can do is likely we can value that is Vg at, okay, I'll do in next step. So this is going to be now sine kxa by 2 cos ky a by 2 plus this will go long, right? So what I can do is I can put the value directly, guys. That will be better. So this is Vg at pi by a comma pi by a comma 0. Okay, so simple, guys. This is we can take minus common, and minus minus going to be plus. So this is going to be 2 epsilon 0 ka upon h cut. Here we'll put the value. So here 1 upon kx, okay, into, so here we'll put pi by a, right? So pi by a, and this is going to be pi by cos pi by a, right? So this is sine pi by this is going to be sine, I will put in place of kx, I'll put pi by a, means this is going to be sine pi by 2. Sine pi by 2 is 1 into, here I'll put y equal to pi by 4, pi by a, right? So this is value is going to be again 0. Minus here I'll put cos pi by a, right? Cos pi by a means there is the y, z is cos 0, right? Cos 0 is 1, and this is 1 into 1. Sin pi by a, pi by 2 is 1, right? And similarly in this one, this is going to be 1 upon plus 1 upon ky plus 1 upon ky, again this same thing. If you put this cos pi by a, this is cos pi by a, this 90, and means this is 1 into 0, 1 into 0 plus this is going to be sin pi by a pi by 2 and sin cos 0, right? This is, that is 0, means 1 into 1 plus 1 upon kz, this value is going to be 0 into 0 plus 0 into 0, because if you put this kz value, right? So there is a kz sin 0 0, there is a kz sin 0 0. So this velocity is going to be Vg at pi by a comma pi by a comma 0. So this value is going to be 2 epsilon 0, my apologies, 2 E0 Ka upon h cut, 2 E0 K upon h cut, and this value, this is 0 value, this is 0, this is 1, 1 into 1, 1 plus 1, right? So this is going to be 1. This is just 0, this is 0, this is 0, this is 1 value, 1, and this is plus, guys, okay? So this is going to be 1 upon kx plus 1 upon ky plus 0. Okay, so this is the answer, guys. You can write 2 epsilon 0 Ka upon h cut into 1 upon kx plus 1 upon ky. Okay, 2 epsilon 0 Ka upon h cut into 1 upon kx plus 1 upon ky. This is the answer. Okay, guys. Next question. Next is, so if you have to find the velocity at pi by a comma pi by a comma pi by a, right? So this value is going to be, if you do that, this value is going to be epsilon 0 Ka upon h cut, and this value is going to be 1 upon kx into 1 into 0 minus 1 into 1, this minus we have taken from, right, plus, and then plus 1 upon ky, this will be same 1 into 0 plus 1 into 1 and plus 1 upon kz, and that is going to be, we put this value, so this value is going to be 1 into 0 into 1 into 0. This is because cos pi by 2 is, cos pi by 2 is 0, kz into 1 upon 1 upon 0 plus 1 upon 1 into 0. So this complete value is going to be 0 at velocity at pi by a, pi by a, pi by a. Okay, this is the answer, guys. Okay, well, next is superconductivity. I'm going to start today. Okay, superconductivity. So superconductivity, superconductivity. Okay, so I'm going to explain superconductivity. Before that, I'll explain conductor. Okay, so conductor, what happens in conductor? Okay, conductor we already know. Okay, we have studied in class 11, 10, 11, 12, and BSc, MSc. So conductor means that we know, right? There are free electrons in conductor and they move with drift velocity, right? And then current is produced. So in conductor, that is, if we increase the temperature, okay, if we increase the temperature in conductor, that means the resistivity of resistivity will also increase. Okay, so if we increase the temperature in conductor, the resistivity will also get increased. That means the conductivity is going to be decreased, right? Conductivity is going to be, conductivity will decrease. Okay, conductivity will decrease. That means current will decrease, right? Current will decrease. So this is what happens in conductor, right? If we increase the temperature, the randomness of motion of electron will increase, means resistivity will increase. Resistivity will increase means increase means conductivity will decrease, because resistivity is inversely proportional to conductivity, right? And if conductivity is decreasing means current is decreasing, right? So this is what happens in conductor. Okay, and since when we increasing T, okay, that time resistivity is increasing, right? Resistivity is increasing, right? So it means they have plus V, means positive temperature coefficient. Okay, positive temperature coefficient. Okay, positive temperature coefficient. Okay, positive temperature coefficient. So this is the conductor, guys. Okay, now this one, guys. So in case of superconductor, okay, superconductor, superconductivity. In case of superconductivity, right? So if in superconductor, if we increase the temperature, okay, if we increase the temperature, it means resistivity will increase. Okay? If we are increasing the temperature in superconductor, resistivity is also going to be increased, guys. Okay, and similarly, if we decrease the temperature in resistor, that means resistivity is also going to be decreased, means Decreasing the temperature of superconductor conductor means if you are decreasing the temperature, that resistivity is also decreasing. And guide at T equal to, at certain temperature T equal to Tc or T equal to Tc, that is called critical temperature or transition temperature. So what is happening is, in the conductor, if we decrease the temperature, right? If we decrease the temperature, the resistivity is going to be decreased. The resistivity is also decreasing, right? At certain temperature, that is T equal to Tc, that is called transition temperature. Transition temperature. Transition temperature. At certain temperature, that is transition temperature at T equal to Tc, what we have seen is the resistivity is suddenly becomes 0 or tends to 0. Okay, so resistivity becomes 0. Okay, and it means the current in conductor becomes infinite, right? And that is called superconductor. Okay, that is called superconductor. So if we decrease the temperature of material, right, resistivity is decreasing at certain temperature, that is at critical temperature or transition temperature. What we have seen is the resistivity becomes 0 or tends to 0. Okay, resistivity becomes 0 and the current becomes infinitely large, or that is very large, right? And that current tends to infinite. Okay, and that condition of the conductor is called superconductor, means that is called superconductor. So if we decrease the temperature of conductor at certain temperature, or that is at critical temperature or transition temperature, the resistivity becomes 0 and conductivity becomes infinite, right? And that is the state of superconductivity. That is the superconductor. Okay, I will explain by I'll explain it by graph as well. Okay, so if we draw the uh, graph between temperature. Okay, so what happens is the temperature, this one, the conductivity, as we decrease the temperature. Okay, as we decrease the temperature, the resistivity. Okay, as we decrease the temperature, this is resistivity. As we decrease the temperature, okay, so resistivity also gets decreased. Okay, but at certain temperature, this resistivity becomes 0. This one, this becomes 0 at Tc. Okay, at certain temperature this becomes 0. So this is the normal conductor, guys. Okay, and as it becomes 0, then current or conductivity is infinite in this case, and that is called, this case is superconductor. At after this point, it becomes that normal conductor becomes superconductor. Okay, and T is greater than T. So if we keep on decreasing the temperature of normal conductor at certain temperature in some material, at certain temperature, that is called transition temperature or critical temperature, the resistivity becomes 0 and the conductivity is infinite, and that state of the conductor is called superconductor, the superconductive conductive state, and that is called superconductor. Okay, well, this is important graph, guys, you should know. Okay, so now I'll write something like there are some material, there are some materials when cooled down, when cooled down, when cooled down, when cooled down below a critical temperature, below below a critical critical temperature, their resistivity becomes zero. Their resistivity their resistivity becomes zero. Okay, and they behave like a zero, and they behave like and they behave like behave like a perfect perfect diamagnetic diamagnetic material. Okay, so there are some materials when cooled down below a critical temperature, their resistivity becomes zero and they behave like a perfect diamagnetic material, superconductor, right? Diamagnetic material. Okay, so now perfect diamagnetic material. Okay, they are yeah, like a perfect diamagnetic material. Okay, so now I'm going to explain that perfect diamagnetic material and a Meissner effect. Okay, so perfect diamagnetic perfect diamagnetic perfect diamagnetic material. ठीक है, perfect diamagnetic material. Okay, perfect diamagnetic material. Okay, or Meissner effect. Okay, please, I'm going to write Meissner effect. Meissner effect. Meissner effect. Okay, so for superconductor we know this or superconductor, and they are like diamagnetic material. Okay, rho is zero, guys. Resistivity is zero and conductivity is infinite, right? So since we know J equal to sigma E, right? Ohm's law, J is sigma E, that current density is conductivity into electric field, right? So from here E is going to be J upon sigma, and sigma is infinite, right? So J upon sigma means that infinity means zero. So in diamagnetic material, and those are superconductor, right? In diamagnetic material, rho is zero, sigma is infinite, and E is zero, right? Zero. So here this is the case, guys. I'll write later. Here you can see. So I'll just explain this. If it is a conductor, guys, if we apply the magnetic field, okay, so magnetic field line will pass through this material, okay, for of conductor, right? Like this. If we apply the magnetic field in case of normal conductor, right? But in case of diamagnetic material, right, which are superconductor also. So in case of diamagnetic material, what happens is, this is the diamagnetic material, guys. So when we if we apply the magnetic field, right? So magnetic field line doesn't penetrate this superconductor, or so this diamagnetic material, guys. So what will happen is they will come like this and they will go like this. Okay, so they passes from there. Okay, like this. like this, then this. Okay, they pass like this, guys. They don't penetrate. They don't penetrate from the this diamagnetic material. Means in diamagnetic material, B in the magnetic field inside the diamagnetic material is B in is 0. Okay, this is the Mesmer effect. Okay, B in is 0. So when so in normal conductor, it passes through the conductor, right? But if we apply the magnetic field in the diamagnetic material, that magnetic field line doesn't penetrate the diamagnetic material, and they goes from they change their path. Okay, and they passes outside of the from outside of the diamagnetic material. Okay, so inside the diamagnetic material, the P in the magnetic field is 0. Okay, so in that case, what happens is, it means B in, that is magnetic field in a diamagnetic material, inside diamagnetic material is 0. Okay, and we have a formula, guys, that is mu 0 into H plus M equal to B in, magnetic field inside the diamagnetic material. Okay, so here so since magnetic field inside diamagnetic material is 0, so it means mu 0 into H plus M equal to 0. So from here, value of H is going to be minus M. Okay, important one. H is that applied magnetic field. Okay, which this magnetic field which we have applied. Okay, H is applied magnetic field or magnetic field intensity. Okay, applied magnetic field. Okay, and X is the, and also, guys, X, this is the magnetic susceptibility. Okay, and magnetic susceptibility is equal to M upon H. This is magnetic susceptibility, magnetic susceptibility, and this is, and M is magnetization, guys. Magnetization. Okay, and value of M, that magnetization, is sigma small m upon V. Okay, that is small m is magnetic moment. So sum of magnetic moment per unit volume. Okay, so this is magnetic. This is magnetic moment. This is magnetic moment. Okay, so this is important result, guide. Okay, M is the magnetization. Okay, so H equal to minus M. So this is in case of diamagnetic material. Okay, and susceptibility for diamagnetic material is going to be minus 1, right? Because H equal to minus M, right? So this is going to be minus M. This is susceptibility for diamagnetic material is minus 1. Okay, this is the one. Next is also, guys, this one. If you draw the graph between critical magnetic field versus temperature, okay, critical magnetic field versus temperature, so we got this graph, guys. This is at critical temperature, that is transition temperature, and this is at SC at 0 Kelvin. Okay, this is important. Okay, and critical magnetic field, this is critical magnetic field, right? Critical magnetic field There's a formula, guys, very important formula. You will get questions, okay, in the examination. Okay, very important formula. You need to note down and memorize it, guys, and solve questions using this formula, okay, related to this formula. So the magnetic critical magnetic field at temperature T is equal to critical magnetic field at 0 Kelvin into 1 minus T upon Tc whole square. T upon Tc whole square. Okay. So critical magnetic field at temperature T Kelvin is equal to Sc, critical magnetic field at 0 Kelvin into 1 minus T upon Tc whole square, where T is critical temperature. Okay. This is very important formula. You need to note down. Okay, this one Sc this one is the critical temperature or transition temperature. Okay, and also, guys, at 0 Kelvin, this SCT magnetic field at temperature T is going to be equal to magnetic field at 0 Kelvin. Okay, this one, and in that case T is going to be equal to Tc. Okay, so this is important thing, guys. Okay, guys, so I'm going to stop here. Remaining part will do in next class. And guys, also I would request the student who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay, guys, thank you so much. Bye now.